So we're now moving on to the two-axis theorems. We're going to start off with the simpler one, which is the perpendicular axis theorem. So the perpendicular axis theorem states that if Ix and Iy are moments of inertia through two perpendicular axes through a laminae, then the moment of inertia of a third perpendicular axis Iz is given by Iz equals Ix plus Iy. So what that means is if we were given an object here and it's rotating about these two axes, if we had a third point which is perpendicular through, or if we decided to pick a third axis perpendicular through one of them, then it's simply the moment of inertia of this third axis is the sum of the moments of inertias of the two axes. So the proof of this is relatively simple. So if we have a laminae on the xy plane and we pick some point mass delta m, then the moment of inertia at that point is the sum of small increments delta m by the distance z squared from the intersection of the axes. By using Pythagoras' theorem, we know that z squared is x squared plus y squared, so the moment of inertia about z is also the sum of small amounts of masses by x squared plus y squared, which you can separate out into the sum of masses times x squared plus the sum of masses by y squared, and by definition the sum of masses by some distance squared is the moment of inertia about that axis. So we've just shown that the moment of inertia about z is the sum of the moments of inertias about x and y.